In this next example, we're going to do very much the same thing. You have the left side, you got to turn it into the right side. That's how you verify the identity. So we're going to start with the left side. I'm going to write it down. This is my given statement. So I'm going to start doing that. I'm going to write the reasons, but you don't have to. So this is my given, just to kind of remind you of geometry. You should always have a reason for what you're doing, but you don't need to write it down for points. So that is given to us. When I look at this, I typically will try to change everything into sines and cosines if I can. So the first thing that I'm going to try is changing everything into sines and cosines. Yes, I have secant and cosecant at the end, but typically when you try to change things into secants and cotangents, or secants, cosecants, and cotangents, things get messy and they don't really work out for you. But because in the properties there's so many sines and cosines, things tend to cancel and work out better. So in the problem, I have got tangent, cosine, and sine. So the first thing I want to do is change my tangent into a sine and a cosine. So I'm going to do that one right there. So I'm going to replace tangent with sine over cosine. So take out tangent and substitute in its property sine over cosine. The property I just used was a quotient property. So I'm going to write that as my reason to keep track of what I'm doing. So this is like that two-column proof in geometry. Now I see that I'm adding fractions on top. So maybe I could get a common denominator there. I'm just thinking. Let's see. Is that going to help me? I don't know if that will help me very much. Let's go ahead and try it. So on top, I am going to, so right now there's an invisible 1 on the bottom of that cosine. And the fraction that I'm trying to add with it has a cosine. So I'm going to put a cosine on top and on bottom, which is going to change the problem. So I've got sine of theta over cosine, plus, if I multiply those, I'm going to have cosine squared over cosine. So here I got common denominators. Every time you get common denominators, it's so that you can add or subtract the fractions. So now we're going to add these together. That's going to give me sine of theta plus cosine squared all over cosine theta, which is all over sine of theta. So I added the fractions. Then I don't like this double fraction. So now I'm going to try to get rid of the sine. This sine has a 1 on the bottom. So I've got this top fraction divided by this bottom fraction. So I'm going to multiply by the reciprocal. I'm going to multiply by 1 over sine on the top and on the bottom so that I can cancel the bottom fraction. That's going to give me sine theta plus cosine squared theta over sine times cosine. So I multiplied by a reciprocal to get that. I did not use a reciprocal property. I just multiplied by the reciprocal of the fraction. Okay, from here, I still remember I need secant and I need plus cotangent. So when I look at what I have, what's good is that I've got this plus. Somehow I'm supposed to get secant and cotangent out of it. So what I'm going to do now is I'm going to try to split this into two fractions so that I get two different terms. So I'm going to split this into sine over the denominator plus cosine squared over the denominator. We're kind of undoing the addition of the fractions. So I've got sine over the common denominator plus cosine squared over the common denominator. I'm hoping that's going to help me. From there, I can reduce a little bit. So I've got sine on top and on bottom. That's going to leave me a 1 on top. And then over here, I've got cosines on top and bottom, which is going to cancel the square. So now it's just 1 cosine on top. So here I split the fractions to get that. Now I have 1 over cosine plus cosine over sine. And I did that by reducing my fractions. Or you could say, for your reason, we canceled sine and we canceled cosine. Then try to get to your end. We should be at the last step. How do I get secant and cotangent? Well, if you look at your properties, 1 over cosine is secant. So you're going to plug that in. Secant is 1 over cosine. And we have cosine over sine, which is cotangent. So we can plug those in. 1 over cosine is secant. And cosine over sine is cotangent. So we got what we wanted using our properties, using the reciprocal property for the secant, and using the quotient property for the cotangent. And that is the end of that problem because we started with that fraction at the beginning, and we ended up showing that it equals the right side of the equation, secant plus cotangent.